Now getting back to ionic compounds, not all ionic compounds dissolve in water. For example, silver chloride is an ionic compound, and we know it because it has a metal. Any compound with a metal in it is going to be ionic, and it does not dissolve in water. If we put silver chloride in water, it remains as a solid. It doesn't break apart into ions. So it remains a solid. It doesn't dissolve or dissociate. So this is known as insoluble. And we know from our everyday experience that there are substances that do not dissolve in water. For example, rocks. So you will be expected to determine if a compound is soluble or not, an ionic compound is soluble or not in water. And there are a list of rules that are summed up as solubility rules, which you can find in your textbook, and we'll go over right now. So this is table 7.2. I don't know what this is. And you want to have this tabbed or marked off in your textbook so you can easily find it. Now, the solubility rules are divided into two sections, soluble and insoluble. Soluble means it dissolves in water, and for ionic compounds, if something dissolves, it means it dissociates. And insoluble means it doesn't dissolve, and so it won't dissociate. So let's look here at our alkali metals, lithium, sodium, potassium, and then this polyatomic ammonium, as well as these two anions, nitrate and acetate. As long as an ionic compound has any of these ions, it is always going to be soluble. Now, if a compound has these halogens, chloride, bromide, or iodide, it is usually soluble. The only exception is if these halogens are paired with silver, mercury, or lead. Then it is insoluble. And sulfate is usually soluble except if it is paired with these alkaline earth and lead. Strontium, barium, lead, and calcium, then it becomes insoluble. Now the compounds that are usually insoluble will have hydroxide and sulfide. But here are the exceptions. Of course, if it has lithium, sodium, potassium, or ammonium with it, since these have no insoluble exceptions, then it has to be soluble. And when sulfide pairs with calcium, strontium, or barium, then it is soluble. And the same thing with hydroxide, except it's just known as slightly soluble. And then carbonate and phosphate are typically going to be insoluble unless they are paired with these cations that have no insoluble exceptions. So to use this table, you basically are going to be asking yourselves, using this table and looking at a compound and asking yourself, does the compound contain any of these that have no exceptions? If it contains any of these 6 ions, then it has to be soluble. If it contains chloride, bromide, or iodide, it might be insoluble, but it's only going to be insoluble if it contains these 3 ions, silver, mercury, and lead. Otherwise, it's going to be soluble. If the compound contains sulfate, it's likely to be soluble unless it contains one of these 4. Then it's going to be insoluble. And the same thing when we're looking at our insoluble. If a compound contains hydroxide, it's going to be insoluble unless it contains one of these 4 cations or one of these 3. If it contains any of these, it's going to be soluble, otherwise insoluble. If it contains sulfide, it's going to be insoluble unless it has these. And if it contains carbonate or phosphate, it's going to be insoluble unless it contains these. So let's just look at some examples. Let's erase what's on the board right now. And I want you to take a look at these compounds. And I want you to pause the slide and look at your table and figure out whether these 4 compounds are soluble or insoluble. Once you figure it out, restart the PowerPoint. So let's look at our first example here, silver iodide. If we look at our solubility chart, silver is nowhere to be seen, but we do have iodide, and iodide is soluble, it's in the top part, unless it's with silver, mercury, or lead. So since this is one of the exceptions, our silver iodide is not dissolvable, so we put an S here, which means it's a solid. It does not dissolve. Now let's look at silver nitrate. We know from this example that silver is not in our chart, so we've got to find nitrate. Here's nitrate. No exceptions to its being soluble. So therefore, silver nitrate is going to be AQ. And since this is an ionic compound, we know that this would dissociate into the 2 ions that make it up when it is dissolved in water. Now let's look at our next example, lead sulfate. If I look over here, I don't see lead, but I do see sulfate. Sulfate is in the soluble section, except when it's paired with one of these 4 cations. And we see that lead is one of the exceptions, so lead sulfate is going to be a solid. Calcium nitrate. If I look here, I don't see calcium anywhere, but here is nitrate, and it has no exceptions, so anything with nitrate is going to be AQ. So if this was dissolved in water, it's going to dissociate, since it's an ionic compound, into the calcium cation and then 2 nitrates. Now these 2 nitrates are going to be far apart from one another, even though they're put together here. This 2 just means we need 2 nitrates to cancel out that positive 2. In solution, all of the anions are going to be separated from one another, and each nitrate is going to be completely surrounded by water, and each calcium is going to be completely surrounded by water.